Okay, good evening, my dear students. Welcome to Gradeup, India's biggest e-learning platform. So, I welcome you all to this live session on the theory of machines, dynamic analysis of single slider crank mechanism. Okay, very good evening. Just please respond to my my audio and video is clear, so I can proceed my session. Good evening, all of you. Very good evening. I want a response from you guys, like my audio and video is okay, so that I can start with my session, because today's session will be the dynamic analysis of single slider crank mechanism. In the previous session, we discussed about the kinematic analysis of single slider. So this is a continuation of the previous lecture. Okay, so in the previous lecture, we have not considered any forces which is being exerted on the different members of the single slider crank mechanism. But in today's session, we'll be taking into account all the forces, how the different forces are acting, and how to calculate these forces. We'll be talking about in today's session. So I welcome you all to this Gradeup platform, the GATE channel, where we'll be having the live free classes for all the GATE aspirants. Okay. So this is Sooraj Gopi. Very good evening, all of you. And please respond. Am I audible or not? Okay. If I talk about the WHO, this was the regulation given by WHO, how to wash your hands. So, so there are basic 12 steps to wash your hands to protect yourself and against, and also your friends, family members, everyone can pass on this information to how to wash your hands with 12 basic steps. Okay. So if I talk about the starting step, we're having you should be having wet hand, then apply soap, then you need to rub your hands like the step 3, 4, 5, 6, 7, 8, 8 steps. Then 9 step is you need to rinse your hand, and after that you need to clean your hands. Okay. Very good evening, Sri Kumar. Clearly audible. Okay, thank you. And if I talk about the helpline number, because at this state, as all you know, COVID-19 is one of the most deadly virus which is now affecting globally. So we all need to stand together to fight against this virus. For that, there is a helpline number given by the Government of India, that is +91 +91 11 23978046. Okay, is that clear? So let me start today's session with, and I want everyone to please have a very good uh, energy, because I want to be discussed in a very effective manner. Okay. And you can reach out for any guidance if you require any guidance or support. Definitely you reach out this number, or any technical queries you can reach out this number. And it's a control room number, national level number, where you can definitely reach out to one of the experts who will be helping you out. Okay. Very good evening, Pawan. Now, I introduce myself. My name is Sooraj Gopi. I have 5+ of years experience. I have masters in thermal science and engineering. I have mentored more than 5,000 students for GATE, ESE, and SSC JE. And area of expertise is mechanics, thermals, and applied heat transfer, industrial, and theory of machine. Okay. So this is my area of expertise, where I usually take the classes for all the GATE, ESE, and SSC JE aspirants. Good evening, Joshit. Very good evening, Vivek Reddy. Okay, now let us start today's session. In the previous session, we have talked about the kinematic analysis, in which we have derived the equation of velocity of piston, acceleration of the piston, and also the angular velocity and angular acceleration of the connecting rod. Okay, fine. So today we'll be taking out the forces, because as this is a dynamic analysis, we'll be taking into consideration different forces on which the piston is acting. Okay. Very good evening, all of you. Sir, when will be industrial be starting? Most probably after 1 month. Okay, industrial will be starting most probably after 1 month, or let me check with my team. Okay, don't worry, it will be, if it is already covered, or it will be started, and you will be notified for that. Okay. Now, this we have discussed in the previous session, in which we have calculated the velocity, acceleration, Uh, Connecting rod, we have calculated alpha and omega. Video is little bit sloppy. Okay, actually, it's heavily raining outside. That might be the reason of the stucking due to network issue. Very good evening, Aditya, Amit. Just bear with me for some more time because net will be the problem will be sorted. Okay. Ramesh Mon, hi, Amit. Now, in the previous session, we have calculated velocity of a piston. Velocity of piston. Okay, what is velocity of piston? We have found out the expression r omega into sine theta plus sine 2 theta by 2n. Fine. This we have derived the expression, and if I talk about the acceleration of the piston is equal to r omega square cos theta plus cos 2 theta by n. Okay, so this we have derived in the previous session, and no problem, audio and video is good enough. Thank you, Aditya, for your feedback. Now, this we have discussed in the previous session. Now we'll be using this expression in today's session. The acceleration of the piston will be used. Okay, now let us have an idea. Now, can anyone tell me how many forces are acting on a piston when, if I talk about a horizontal engine, single side mechanism, if we are talking about a horizontal engine, which I have shown you the figure, can anyone tell me on the piston how many number of forces are acting? Because piston will be having a reciprocating motion. So how many number of forces are acting on the piston? And the total force or acting on the piston, the net effective force is known as the total piston effort. Okay, we'll be having a discussion on this in detail. First, tell me how many forces are acting on the piston. Yes, I want a response from all of you guys, because without you there is no point of taking a live session. I want interaction from all of you guys. Two forces. Okay, now don't see this diagram. Okay, just name it. What are the different forces that will be acting? Okay. Now, if I talk about the number of forces, first force that will be acting will be the pressure force. One second, guys. That will be the pressure force. Okay. One will be pressure force, and second will be, yes, pressure force, friction force. Exactly. Very good, Ramesh. One will be having one friction force, because definitely we're having a reciprocating motion, so we'll be having a friction force. Due to network issue, I am seeing the video is also stuck in, so just bear with me for some more time till net is being sorted. Sri Kumar is saying 3. Very good. So two forces, pressure force and friction force. Can anyone tell me what will be the third force? And I'm giving you a hint. We'll be having 3 forces: pressure force and thrust force. Exactly. The third force will be the inertia force. Yes, exactly. Very good, Vikas. Inertia force. Okay. Very good evening, all of you. So we're having 3 forces on the piston. One is pressure force, second is friction force, and third is the inertia force. Inertia force, what is inertia force? Is basically a fictitious force. You all know the definition of inertia force. So when you apply D'Alembert's principle, we'll be getting the total piston effort. So when you take into account all these forces, okay, so net force acting on the piston will be known as the piston effort. Okay, will be known as piston effort. Clear? Fine. The afternoon it was fine. The video was also fine. Due to rain, I suppose it is having a lag. Okay, so all the three forces will be acting on the piston. Now let me discuss individually. Now this is piston, okay, and there is a nomenclature I'll be telling you. This F is basically your piston effort. Okay, this F is basically the piston effort. This normal Fn is the normal force. Fc, you might be seeing the Fc force on the connecting rod. This is the force along the connecting rod. Next is Ft. Ft is tangential force, or also known as crank effort. We'll be discussing that also in detail. And the fifth force will be the radial force along the crank. Okay, so these are the different forces which are acting on the piston. Okay, now let us understand one by one what is basically the gas pressure force. Now let us suppose this is the piston, this is your piston. Okay, let me write this is your piston. So on the both the sides will be having the pressure being acting. So please tell me what will be area A1. If I want to write A1, what will be the area A1? If I suppose the diameter is capital D, the piston diameter is capital D, then your area A1 will be the cross section area. That will be equal to pi d square by 4. Pi d square by 4, that will be the area. Okay, now if I talk about A2, A2 will be the net area, because now if this is a piston, on the end will be having a connecting rod being added. So your net cross section area will be pi by 4 d square minus d square, where small d is the diameter of the connecting rod. Area of the bore, yes, exactly. Very good, Ramesh Mohan. So if I want to calculate what is the net pressure force, if I denote the pressure force as, let us suppose this is Fp, then Fp is equal to P1 A1 minus P2 A2. So this will be a net pressure force. Okay, so this will be a net pressure force, cross section area. Very good, Aditya. So this is your net pressure force denoted as Fp, P1 A1 minus P2 A2. Exactly, Vivek, correct. Now, if I talk about the frictional force, let me go to the diagram, previous diagram. Now, the piston is basically, if I talk about this as a piston is basically having a reciprocating mechanism. Okay, reciprocating movement. So what will happen? Obviously, opposite to the direction of motion will be having the friction force. So if let us suppose this piston is moving in this direction, so your friction force will be in this direction, will be a friction force. So you'll be having a friction force F. Okay, exactly, area of piston minus area of connecting rod. Very good. Now if I denote the friction force as F, so it will be basically either a plus value or a minus value. Okay, it will be plus minus value. I'll be talking about that also, don't worry. And if I talk about inertia force, what is inertia force? Denoted as Fi. Fi, inertia force. Okay, so Fi is basically equal to mass into acceleration. Fi is equal to mass into acceleration. What is acceleration? Acceleration is of that piston. Ishwar Rao is saying video is lagging. I know due to rain, outside is raining heavily, so that is why there is network issue. Okay, don't worry, just let me check with my net once again. Just stay with me, guys. Okay, it's already net is there. Video lagging, sir, no sync at all. I truly apologize for that, because due to rainfall I'm not able to get proper net connection today. Don't worry, let me try one more time. Okay, so inertia force, just have a look at this board. Inertia force will be denoted as Fi is equal to m into a. Okay, it is denoted as m into a. Clear? Now if m into a, now acceleration of the piston, I have just now told you about the acceleration of the piston. So acceleration of the piston, the formula is r omega square cos theta plus cos 2 theta by n. What is theta? Theta is the angle between the crank and the line of action. This is theta. Okay, this is the angle theta, and this is beta, the angle between exactly Newton's second law of motion. Very good. So beta is the angle between the connecting rod and the line of action. Okay, fine. So we'll be using the same expression. Just bear with me for today, because the climatic condition is not at all supporting me. So I extremely sorry guys for that. Okay, this is equal to m into a. A is this is r omega square, r omega square into cos theta plus cos 2 theta by n. Due to internet issue, this is also stucking guys. Cos theta plus cos 2 theta by n. Okay, fine. Just try to manage for today. Don't worry. If possible, I'll be taking more session for the same topic. Don't worry. If you're not able to understand, just do let me know. I'll be taking more sessions like this. Fine. Whenever I'm getting a proper net for that. Now, force, inertia force equal to mass into acceleration. This is mr omega square cos theta plus cos 2 theta. Clear? Now, if I summarize it, if a student gets marked below cutoff, then what he is able to see is scorecard. He'll be getting the score, gate score, right? If I talk about, if you are talking about MS Shekhawat, if you are asking about the gate examination, if you are not able to clear the cutoff, don't worry, you'll be getting a gate score. Okay, gate score is given to all the students whether you are qualifying or not. So net piston effort, if I use D'Alembert's principle, I'll be using D'Alembert's principle, the net piston effort will be equal to Fp minus Fi, because inertia force will always be acting opposite to the pressure force, plus minus this your friction force. Now how we are getting a friction force to be plus and minus? Can anyone tell me how I'm getting the friction force to be a plus and minus? Just see this diagram. Just see this diagram. Always look at this diagram. When always remember, this pressure force will always be acting. Let us suppose this is the pressure force. The pressure force is always along the right hand side direction. Let us suppose your piston is moving from left to right. If it is moving from left to right, then the friction force will be as it is, which I have shown in the figure. If it is moving from right to left, fine. If your piston is moving from right to left, then your your friction force will be in this direction. Okay, and this is the direction of the friction, and this is the direction of Fp, so we'll be having the same direction. So that is why we're having a plus minus frictional force. Okay, fine. Is that clear? So piston effort is equal to Fp minus Fi plus minus F. Exactly, because exactly you are correct. So if I say, let us suppose this, yes, my calci, let us suppose this is the piston. Okay, this is the piston, this is the pressure force always acting in this direction. So if the slider is moving, if the crank is if the your piston is moving in this direction, then what will happen? Your friction will be in this direction. If your piston is moving in this direction, still your pressure force in this direction, then your friction force will also be in this direction. Okay, in general it is negative, but let me show you the range where F value is positive or negative. There is a range for this, so I've left some space over here. So from 0 to theta less than equal to pi, in that case your F will be negative. If there is pi less than equal to greater than equal to theta, okay, now I suppose you should be having your slider is above the crank. In that case, mg will be positive because it is always supporting it is always supporting FP. If this is your FP, so FP and mg will be in the same direction. And if in this case where your piston is crank is above piston, in that case this is your FP, this is your FP, okay, and mg in this direction will be having a negative mg. Okay, is that clear? So this is basically a compressor and this is basically an engine. Is that clear? Prabhakaran, Abhishek, Vikas, Sri Kumar, Vivek Reddy. Now it's okay, or still the lag is there? Please tell me, guys, if there is still a lag, and I can. Okay, so now you have understood what is the total piston effort which you are having. Okay, now next is on the connecting rod, how forces are acting on the connecting rod. So let me draw the diagram. Let me draw the diagram for you guys. If this is the piston, if this is the piston, this is the connecting rod, then the connecting rod will be acting, the force on the connecting rod will be along the connecting rod force. So this is FC, okay, and this is the direction of F, the net your piston effort. This is piston effort F, okay. So your video comes after the audio. Shouldn't be lagging right now. Please tell me okay, so don't worry, just be with me for a while. So FC is in this direction, okay, so let me complete this. This is beta. So I can write this as and your Fn is acting like this is a piston, this is Fn and this is the piston, okay. So FC in this direction, this is the net piston effort, this is your piston effort. So I can write that F is equal to FC is equal to F upon cos beta. I can write it like this. It's a very basic thing. This is the connecting rod. It is pushing the piston in this direction. Okay, so we'll be having FC is equal to F upon cos beta. Okay. If I want to calculate what is the normal thrust, that is the F1, because the force, let me show you the diagram now. This F1 is the normal thrust, will be the force will be acting on the cylinder wall. This is the force which is acting on the cylinder walls. Okay, so cylinder walls will be having Fn. So I can write this as Fn is equal to Fc sine beta. I can write this as Fc sine beta, and instead of Fc I can write F by cos beta. So this will be F tan beta. Okay, so Fn, what is Fn? Fn is the total thrust force to the cylinder walls. Okay, so Fn is the total force. Now this is, let us suppose this is the cylinder. So on the walls will be exerting some forces, that is the normal thrust, always perpendicular to the surface of a piston. Okay, now it's, I suppose it's not lagging right now. Now it's okay. Done. Now let us understand. Please tell me if you are having any doubt right now, so that I can explain you in detail. Yes. Now it's okay. Now fine. Okay, thank you. So Fn is the normal thrust force to the cylinder walls, that is F tan beta. Now these two expressions are very important because they are directly or indirectly asking question from this. Okay. Next is radial thrust on the crankshaft bearing, because now let us see how many forces which we have. Sir, is Fc the resultant? No, Fc is not resultant. Let me show you every forces. F is the piston effort. F is piston effort. Okay. Fn is the normal thrust force. Normal thrust force. Fc is the connecting rod force along connecting rod. This is force along connecting rod. Okay. F and Ft. Now if I talk about crank, on the crank we're having two forces. This is your radial force Fr, and Ft is the perpendicular to this. This is perpendicular to this. This is your radial thrust force. Now tell me, if I talk about this as a crank, so which force will be responsible for the torque? Will it will be your uh, will be your crank effort Ft or the radial thrust Fr? Please tell me quickly. Which of the force will be responsible for the torque or the movement of the circular motion of the crank? Will it be the tangential force or the radial force, or the crank effort or the radial thrust? Please tell me quickly. I'm removing everything. Very good, Vikas, Srikumar and Ishwar Rao. Very good. All of you are correct. Now, obviously, because R is passing through the center of the crank, so definitely it won't be producing any torque. Ft, that is a crank effort. That is why we are not saying it as tangential thrust. We are basically nomenclating as the crank effort. What is crank effort? So due to this force only your crank is moving. Okay, so we'll be finding the expression. This is very, very important, this expression. Now, first of all, let us calculate this Fr. Fc we have already calculated. Just now we have calculated Fc. Fc is F by cos beta. Okay, just now we calculated Fc is equal to F by cos beta. Now, if I want to calculate Fr, can you tell me by looking at the diagram what will be Fr in terms of Fc? This angle is theta. This angle is theta. This smaller angle is beta. Now tell me, Fr will be, how to write Fr in terms of Fc? Will it be Fc cos theta, or Fc cos theta plus beta, or Fc sin theta, or Fc sin theta plus beta? You will be telling me, because now I have explained you and the figure is in front of you. Please tell me quickly what will be the radial thrust if I want to write in terms of Fc. So it will be Fc, yes. Ramesh Mohan, Abhishek, Ishwar Rao, Sri Kumar, Vikas, Pavan, please quickly respond. What will be the radial thrust in terms of Fc? Will it be Fc cos theta or Fc sin theta? Very good. Vikas Kumar is absolutely correct. Ishwar Rao is also correct. Ramesh Mohan, how it will be sin? And Sri Kumar, you are only taking beta. You have to take theta plus beta also. If I draw this diagram in a simpler way, this is your Fr. This is your Fr. The angle between, this is your Fc, and the angle between Fc and Fr is theta plus beta. Okay, and perpendicular to this is your Ft. Now you can understand. Now you can understand. Fine. So you can directly write Fr is equal to Fc cos theta plus beta. Is that clear? Now Fc, what is Fc? I can write Fc in terms of F. So F cos beta. So I can write this is F by cos beta into cos theta plus beta. Is that clear? This is the radial force. Raja Gopal, please continue the videos tomorrow. I could have, but due to the schedule, don't worry. If you're having any doubt, I'll be definitely taking one more class for that. Just let us complete this session, and in the end, if I feel if one more session is required, definitely I can take one more session for you guys. Don't worry. Okay. So now you calculate Fr, the radial thrust. Second is the crank effort, Ft. Now you will be telling me what will be Ft in terms of Fc. So this will be Fc sin theta plus beta. Sin theta plus beta. I can write this as F upon cos beta into sin theta plus beta. Okay, so this is your crank effort or tangential force, anything you can nomenclate anything. Very good, Ramesh Mohan, very good. Now if I talk about the torque, because Ft, that is a crank effort, is responsible for the movement, the circular motion of the crank. Okay, so we'll be calculating the torque produced in the crank. Fine. So turning movement on the crankshaft. Okay, so turning moment of the crankshaft or the turning moment on the crank denoted as T. So this will be is equal to T is equal to Ft. Let me write capital F. This will be equal to Ft into R. What is R? This is radius of crank. Okay. So if I take this as crank, Let me take this as crank. This is your connecting rod. This is connecting rod. This is the piston. This is crank. So on the crank, we're having a force perpendicular to this. This is your Ft. This is R. So Ft into R is basically the torque produced. Now, if I want to write this expression, this is equal to F sine theta plus beta upon cos beta into R. Okay. So this is the final expression of the turning movement on the shaft. Very important, because that is also being asked in many problems. Like in GATE examination, they are asking, if a question is coming from this topic, definitely they will be asking the turning moment, because for turning moment you need to calculate the different forces, and where F is, what is F? F is the piston force, piston effort, where F is piston effort. Okay, where F is piston effort, and this is equal to Fp minus F inertia force plus minus frictional force plus minus mg if it is a vertical engine. If it is a vertical engine. Okay, I'm repeating once again, those who not able to understand how F is coming plus and minus. So from 0 to pi, from 0 to pi will be having minus F, from 0 to from pi to 2 pi will be having plus F. Okay, is that clear? Just need to remember, if your movement is from 0 to pi, then basically what is happening, your piston is moving from the inner dead center to the outer dead center. In that case, this is your pressure force. Obviously opposite will be your friction force. When it is moving from outer dead center to inner dead center, in that case pressure force and friction force are moving in the same direction. Let me write it over here so that you are having clarity over this. So inner dead center to outer dead center, and in this case outer dead center to inner dead center. Okay, that is why we are having a plus sign. With respect to pressure force, we are seeing everything. Okay, because we are assuming the net force is acting in the direction of pressure force. Clear? That is piston effort. Now let us have a discussion on this. Please tell me, if I remove this, let me remove this one. Yeah. Please tell me whether the torque is depending on the angle theta. It is basically dependent on the angle theta. You can see from this equation, your torque or turning moment is depending on theta. Okay, so I can write this as your turning moment or torque is basically a function of theta. And also you know that theta is basically a function of time. Theta is basically a function, because at every instant your theta is changing. If theta is changing at every instant, exactly, very good. If theta is changing in every instant, so I can also tell that your torque is also changing at every instant. If torque is also changing at every instant, I can say, because torque is equal to I into alpha, and I is constant for the entire body, so alpha will be also a function of theta. Okay, or we can say alpha is a function of time. I can write it like this. If alpha is a function of time, what does it suggest? Please tell me quickly. If I say angular acceleration is changing at every instant of time. Yes, I'll be taking problem also. I've taken 2 problems for you guys. After this, I'll be taking the problems. Don't worry. So if I say angular acceleration is changing at every instant, what's the meaning of that? That means we are having a rate of change of angular acceleration. That means we are having this entity. What is rate of change of angular acceleration or rate of change of acceleration? Please tell me quickly. What is rate of change of acceleration? What is that term called? Anyone who knows this answer? Ishwar Rao, Vivek Reddy, Raj Gopal, Ramesh Mohan, Shri Kumar, Abhishek. Exactly, very good. This is known as jerk. This is known as jerk. Okay, very good. So what we can conclude from this, every time whenever your crank is rotating, it will be producing jerk. That is why it is mandatory to use a flywheel. It is mandatory to use a flywheel. Is that clear? Is that clear? Because without using flywheel, you can't even you cannot even start the engine also. Okay, you cannot even start the, because what is the role of flywheel? Flywheel is basically absorbing the fluctuations of energy or fluctuations of energy or torque. Exactly, it will be having impact. Very good, because it will be having constant impact. If I'm saying it's a constant jerk, so what will happen? Your piston will be moving like this in a small vibration motion. So you won't be having an effective output. So that is why we are using flywheel to, in order to avoid the fluctuation of acceleration or jerk. Exactly. Okay. So this is the main role where your flywheel comes into picture. Okay, guys, understood? Yes, correct. Very good. Okay, so this basically completes your dynamic analysis. I suppose at the starting the video was not having a clarity, but now it's okay. I suppose the audio and video is now sync. Clear? So this is fine. So that is why we're using a flywheel. You all know why we are using flywheel, but many of the students don't know why, what is the application, what is the drawback in the engine that we are using the flywheel. So this is the explanation why we are basically using the flywheel. I hope so now you have understood clearly how this role of this device flywheel is coming into picture in your single slider crank mechanism. Clear? Let us move to the problem, guys, and I want everyone to solve it. Now I suppose the video stacking is over. Now you'll be having the discussion, problem discussion on this. Theoretical usage is clear. Now let us apply all the theories which you have studied in the past two sessions, that is your kinematic analysis and dynamic analysis, and let us try to solve this problem. Quick recap of today's session. Yes, definitely. I'll due to this issue, video issue, I was not able to deliver the properly. So basically in the previous session we have talked about the velocity of piston and acceleration of the piston. Velocity is r omega sine theta plus sine 2 theta by 2n, and acceleration of piston is r omega square cos theta cos 2 theta by n, where n is obliquity ratio. Okay, and what is n? It is basically L by R, the ratio of length of the connecting rod by the radius of the crank. Okay, now second thing is I've asked you about what are the different forces acting on the piston. So if you're having a piston, definitely will be having a pressure force, a friction force, and an inertia force. So in total, by taking all the forces in collectively, will be having a net force which is known as the total piston effort. I'm having a 5 minutes quick recap of today's session. So all of you, those who are not able to understand, I will be having a clarity on this topic. So by taking all these forces into one picture, that is known as the total piston force, and I'm assume the total piston force is always acting in the direction of pressure force. Okay, so this F is always in the direction of pressure force. This is FP. Now let us understand one by one. Pressure force is the piston. On the left hand side we are having P1A1 and this is P2A2. Why we are having the area 2 to be different? Because at area 2 will be having a small diameter of the connecting rod being inserted into the piston. It will be something like this. This is your piston and this is your connecting rod. So we'll be having a connecting rod. Fine, this is your piston. So that is why this is the effective area. So that is a pi by 4 d square minus d square. Friction force, if I talk about the moment of friction, from 0 to pi, your friction will always act in the opposite direction. From pi to 2 pi, it will always act in the direction of pressure force. Okay, so basically we are calculating in the direction of pressure force, in the direction of pressure force. Okay, fine. Next is inertia force. Inertia force is always opposite force, which is the frictious force, which is equal to mass into acceleration, and acceleration we have studied, it is r omega square cos theta plus cos 2 theta by n. Now what is total piston effort? That will be Fp minus Fi plus minus the friction force. If you are using a vertical engine, now there are basically two types of vertical engine. Either it can be a engine, it can be a compressor. If it is an engine, then definitely we'll be using this configuration where your connecting rod is above the crankshaft. Okay, so this is your in this case your mg will be positive, because your FP is in the downward direction and mg is also in downward direction. In this case, whenever we're talking about compressor, we are having FP in the upward direction and mg in downward direction. That's why we're having a negative sign. Next is your connecting rod force. This is your connecting rod. Yes, this is your connecting rod. So always it will be acting like this. This is your connecting rod force FC. So FC is equal to F upon cos beta. Is the derivation important to remember, or only the formula in GATE more than sufficient? Now, student usually have a doubt, confusion, which will be cos beta, sin beta. So that is why I have taken up the derivation. It's not derivation also, it's basically the understanding. It's pure mechanics. Just you need to see what are the direction of forces it is acting, so that whenever you're solving any problem, you're not able to face any issue. Okay, so for making your understanding level easier, I have taken up the derivation. It's not derivation, basically the understanding of forces, how it is acting. Okay, so normal thrust force is, this is the normal thrust force acting on the cylinder walls. So this is Fn is equal to Fc sin beta, and that is equal to F by cos beta into sin beta, which is tan beta. Next is your crank. On the crank, how many number of forces are acting? There are two forces acting. One is your radial force and second is your thrust force, and due to this thrust force only or crank effort, we are having the turning moment. Due to this force only, we are having a turning moment. Okay, fine. So just you need to take the component along cos theta and sin theta, that is your total force. And in the turning moment, what is turning moment? This is Ft into R, and Ft is F sin theta plus beta upon cos beta into R. This is your total turning moment. And how the flywheel is coming into picture, basically we are having a jerk being associated with this term. What about Fc, sir? Fc, yes, Fc, this is Fc. This is connecting rod force. This is connecting rod force Fc in this direction. Okay, so if you take this as Fc, so if you remove this is Fc cos beta. Fc cos beta is equal to F, fine, or Fc is equal to F by cos beta. If you resolve Fc, then Fc sin will be acting on crank. On the crank, yes, I have taken that. On the crank, we are having this force. Sorry, it won't be. Yes, it will be acting. Fc, I have taken this Fc also. Now look, Ft is basically in terms of Fc only. But I have modified this formula. What is Fc? It is basically F by cos beta. Because ultimately you need to understand. You said only two forces will be acting on the crank. Due to that rotation motion on the crank, will be having two forces only. That is your radial force and your tangential force. Okay, in the problem, crank radius is not given. Let us try to understand this. Let me clarify the doubt of Ishwar Rao. In this case, basically on the crank, due to this crank, we are having two forces being arising, which is Ft and Fr. Fc is basically acting due to the connecting rod. Okay, so there will be in total three forces, but we'll be taking into account only the two forces because Fr is having no turning moment. Clear? Fine. So this was all about. Let us try to solve this. Now, Vivek Reddy is saying the crank radius is not given. I know crank radius is not, because you need to calculate that. Angles are given. Please quickly calculate. Let me extend this. So I got one answer from Vikas, and is absolutely correct. Very good. Option A, Vikas Agarwal. Let us take this as point O. You can calculate by using these angles 30 and 60. Let us suppose this is R. Okay, so what will be OB? OB will be L sin 30. I can write R sin 60 is equal to L sin 30. I can use this expression. Yes, Vivek Reddy is absolutely correct. Vikas also correct. So I have got two students who have responded correctly. So option A is the correct answer. Those who have so from this expression, I suppose you are calculating the value of R, and you will be getting 5.77. 5.77 centimeter will be the value of R. After getting the value of R, next is N is equal to L by R. L by R will be root 3. You'll be getting L by R is equal to root 3. Next, they are asking inertia force. What is inertia force? Fi. They are asking Fi. Fi is equal to m into acceleration. Acceleration is r omega square cos theta plus cos 2 theta by n. Okay, fine. So everything is given, mass is given, radius is given, you have calculated. Omega is 300 rpm. You will be calculating that omega is equal to 2 pi 300 by 60. So this will be 10 pi radian per second. Just put the value, theta is equal to 60. This is theta. The angle made by the crank is theta. This is theta and this is beta. So you'll be getting approximately 24.08 Newton. So closest answer is option A. Very good. Very good, Sri Kumar, Vivek, Ishwar Rao. Very good. You all are correct. Let us go to the next problem. Yes. Option A is correct. A slider crank mechanism with a crank radius 200 mm. Okay, this is crank radius. R is given. And the connecting rod length is 800 mm. This is your connecting rod L. The crank is rotating with 600 rpm with counterclockwise. That means in this direction. This is your omega n is equal to 600 rpm. Makes an angle theta is equal to 90. Let us suppose this is beta. Neglecting the inertia forces, calculate the turning moment. Yes. You have to tell me what is the turning moment. That means they are asking the value of T, and T is equal to Ft into R. And what is Ft? Ft is equal to F by cos beta into sin theta plus beta into R. Yes, quickly solve it and tell me what will be the turning moment in kilonewton per meter. In kilonewton per meter. Yes, quickly. The force acting on the slider is so net force acting on the slider. This is your piston effort already been given. This is your F, which is piston effort. Piston effort already been given. So you have to tell me what will be the net turning moment. Theta is equal to 90. It's very basic, it's a 1 marks problem. You can directly calculate. And thank you guys for being with me till the end, because I suppose many of the students have left the session due to the lagging. And I'm very thankful for Sri Kumar, Vivek Reddy, Ishwar Rao, Vikas Agarwal for being till the end of the session, because I promise you will be getting us problem solution, which is important for the examination point of view. Yes, quickly tell me what will be the turning moment on the crank. Theta is equal to 90. Sin 90 plus beta is cos beta. Cos beta and cos beta will be cancelling out. Very basic. So this will be F cos beta sin 90 plus beta into R. Now sin 90 plus beta is cos beta. So this will be cancelling out. So ultimately we are having an expression of F into R. What is F? F is 5, R is 0.2. So this is 1 kilonewton meter. Very good, Vikas and Ramesh Mohan. Both of you are correct. And also Ramesh Mohan, thank you for being till the end. Yes, approximately 1. If you calculate by using the beta value, ultimately you will be landing up with the same equation. Okay, so it's basically just you need to cancel out very direct formula based problem. So your net torque acting on the crank at that instant will be 1 kilonewton per meter, 1 kilonewton meter. Okay, yes, it's in kilonewton meter because the force is given in kilonewton. So your final expression will be in kilonewton meter. Very good, Abhishek. Sri Kumar, Vikas, Ramesh Mohan, all of you are correct. Beta is 14.47. Yes, exactly. Very good. Beta will be 14.47. You can calculate by using this sin beta. Sin beta is equal to R by L. That is 0.2 by 0.8, 1 by 4. So beta will be 14.47. Exactly, very good. It was that was not required, but still, if you have calculated, don't worry, because ultimately this problem is one liner. Okay, if you're having a tougher problem where you need to calculate more number of forces, in that case you need to calculate beta also. Clear? So thank you guys, this was it from my side. I suppose it's pretty much clear, and sorry guys for that interruption which we had at the starting, for because it was raining outside, so I was not able to, it is not in my hand to take any appropriate steps. Okay, fine. Please ask me any doubt. If you are having any doubt from theory of machine or this topic, just do let me know. I can respond it right now or else we can conclude this session, and we'll be meeting again on Monday, I suppose, with the very important topic of theory of machine, which is vibration. SS Ratan is very good book. Sir, present city with I'm staying at Gurgaon. My hometown is in Gurgaon or Gurugram. The new name of this Gurgaon is Gurugram. So I'm staying in Gurugram. So it was raining today, so that is why there was some difficulty. But in afternoon session, it was good. Monday 9 o'clock, same time. Sir, how to prepare for interviews? Look, for interviews, just take up 2 or 3 subjects which you are comfortable in, and try to have a good knowledge on that 3 subjects. Okay. That is more than sufficient. And if you are B.Tech final year, they will be like pretty much interested. It depends upon which PS you are applying. Okay, if you're going for BARC, you'll be having a very lengthy interview. If you're going for IOCL, NTPC, it will be having 20 or 25 minutes max. Yes, it will be live on YouTube only. Abhishek, no, I was early planning for that, but now I have reduced the topic. Next topic which I'll be taking will be vibration. Okay, so vibration is very important, and many of the students have texted me, messaged me, like please take vibration topic. So definitely I'll be taking vibration topic, very very important. For IOCL and NTPC, just make sure you're having a thermal engineering or thermodynamics. What is next batch schedule? Satyavan Suryavanshi. Sir, is Gradeup classroom free? No, it's not free. But let us talk about Vision 2021, because as you have asked me, we are having a batch 2 being launched. Okay, it's not free, but you can definitely go for your scholarship. Weightage of this topic in GATE is having a very good weightage from like 8 to 12 marks. 8 to 12 marks, definitely you can go for that. Heat transfer class, I'm planning for that. And yes, on Gradeup app, I'm taking heat transfer classes daily, but due to some schedule issue, we are having a proper series for that. Don't finger on your concept on your fingertips. That will be series on the Gradeup app, only exclusive for the Gradeup app platform only. It won't be there in the YouTube. So every day we'll be having 1 hour or half an hour classes on heat transfer. So we are planning for that, and every subject will be taught on that Gradeup app. So you can definitely go for that. What are the topics you're not going to teach on YouTube? For theory of machine, I won't be taking your flywheel governors, because this is very derivation based. So better, I was planning for earlier, I was planning for to take that classes, but I've skipped that. Okay, so thank you guys, and let me complete this. So we are having an evening classes at 7 to 9, and 9:30 to 11:30 is the timing of 9:30 to 11:30 is the timing of the vision classes, Monday to Friday. And if you are having this, any of the one is you are fulfilling the criteria like GATE qualified or IIT and IIT government B.Tech students or ESE plan qualified, definitely you can avail a 50% off on the MRP. Okay, and for more info, like if you want to ask about any fees related queries or any queries like what will be schedule, because when you enroll for this, you'll be having an access for the complete schedule. We'll be having a PDF. Is coaching compulsory to qualify ESE, Ishwar? Or no, it's not compulsory, but you need to be having a proper strategy for that, because ESE requires a dedication. ESE basically requires patience, and it requires basically right strategy. It requires right strategy, and what to study and how to study, that is very, very important. Okay, so thank you guys for being with me till the end. Sorry guys for the earlier stucking of the video. And again, I'm seeing it's raining outside, so let us quickly conclude the session so that you're not having any video related problem. Exactly, Shri Kumar. He is exactly correct. Coaching is only a medium. Okay, it's just act like a catalyst. Only thing is you need to be having a right strategy. You should be dedicated and patient for every, because I've seen students usually start their preparation for 1 or 2 months. After that, they become lazy, or they are not they are not basically dedicated. So for ESE qualification, you can see 60% marks is required to qualify ESE. Okay, you know that. But in GATE, you required more than 90% or more than 80% marks to get into the PSU, a short call into the PSU. So you can directly see the difference between the two. ESE syllabus is very vast, and GATE is a confined syllabus, but they will be asking conceptual base. Okay, so thank you guys for joining with me on the live session on the theory of machine, the dynamic analysis. uh, I suppose now it's clear. Please attempt some problems from your side on this topic, which will make this concept more easier for to understand. Okay, so stay safe, be healthy, don't go outside, just stay at your home, enjoy the live classes at the Gradeup platform. You can prep smart, stay safe, score better, go Gradeup. Thank you, bye bye.